Thank you for coming to my talk. In the talk today, I present a framework for building IoT systems. The framework named Pratipad is leveraging the genuine power of Elixir and Erlang OTP. I hope you all enjoy my talk. Let me introduce myself briefly. My name is Kentaro Kuribayashi. I'm working for GMO Paperboard, Japan. We are running many web services in the domains of e-commerce and cloud platforms. Besides working at CDO, I'm a graduate student studying information science, especially IoT-related technologies. Here's today's agenda. To get started, I explain the background of why I made Pratipad. Then I explain my proposals and their technical details step by step. Finally, I wrap up and conclude this talk. First, I'll explain the background of why I made Pratipad. Elixir is eating the IoT world. I'm not exaggerating. Dr. Takase, a co-leader of Nervous JP, once envisioned a future illustrated at the right figure. Elixir is running on the devices, edge servers, and cloud. Now, Elixir can realize such a new world. I'd like to progress the vision mentioned earlier. What we need to do is to connect things with the distributed Erlang network, and it can mitigate current issues in developing complicated IoT systems. I have a dream that everything is connected as an Erlang node. Nowadays, IoT systems take advantage of edge computing. IoT systems consist of three layers such as device layer, edge layer, and cloud layer. This diagram summarizes the architectural models. These facts bring us complexity in developing such systems. There are three factors that cause such complexity. The first problem is which programming language and communication protocol should we use? The second problem is on the method of communication between the three layers. There are various methods to retrieve data from the device layer. Moreover, it can also be bidirectional. The last problem is that the code base for the data flow tends to be scattered around and hard to grasp. Here, Pratipad counts. It's a solution to the problems mentioned earlier. Pratipad provides a declarative framework for describing bidirectional data flow between the three layers. It's been already published on GitHub. Almost all in the library are currently undocumented, though I'm working on it after ElixirConf. Second, I show you my proposal to solve the issues mentioned earlier using Pratipad. This figure illustrates an example IoT system using Pratipad. This system helps us to work in a sound environment. The devices measure some environmental data such as CO2 concentration, air pressure, and humidity. Then, the edge server implemented by Pratipad adds some extra information like precipitation into data from the devices. Finally, the cloud application analyzes and visualizes the data for the users of the system. The application would send back actuation orders to the device layer to prompt users to open the door. The three layers are connected via the distributed Erlang network with TLS and client certificate authentication. The first proposal is implementing and connecting the three layers using only Elixir and Erlang distribution protocol. Using Pratipad and other neat frameworks, all three layers can be implemented in Elixir, and Pratipad client connects each layer via a protocol defined over the distributed Erlang network. For security reasons, the connection should be encrypted and have an authentication mechanism. I'll show you later how to realize a secure connection in the distributed Erlang network. The second proposal is to provide flexible and bidirectional data flow. There are various methods to retrieve data from the devices. Pratipad allows us to choose which method to use along with the system requirement. In the illustration mentioned earlier, the cloud layer sends back an actuation order when needed. Pratipad also supports the bidirectional data flow. The third proposal is a declarative and easy to grasp data flow notation. Using Pratipad, we can describe data flow into a single file in a declarative manner. It helps us to graph the full data flow in the IoT systems at a glance. Moreover, Pratipad allows us to separate the data flow itself and how to process data on it. It helps us to keep our code base tiny. Then, we'll look into the details of what the Pratipad framework provides. The first one is self-distribution. For IoT systems in Elixir, we can even choose HTTP, MQTT, or some other protocols. Here, we adopt the good and old distributed Erlang protocol. If not, building IoT systems in Elixir is not always a good choice, I think. Erlang OTP has legendary achievements in very large telecom systems. I'm convinced the IoT is like such a system in the current era. However, as Joe Armstrong once said in his paper titled A History of Erlang, the distributed Erlang network is not secure by default. It's been basically for a local and safe environment. So we have to make sure the security of the network by ourselves. By definition, IoT system cannot be local. The I of IoT stands for the Internet. To realize secure distribution with Erlang OTP, we have to meet the two requirements. First, make sure that all connections are over TLS to avoid a man-in-the-middle attack. Second, authenticate nodes before they try to join the network. Pratipad provides examples of how to implement a secure network. To enable TLS for distributed Erlang networks, settings of prot disk and SSL disk opt file are important. This example is taken from an example device implementation using nodes and Pratipad. To pass some extra argument to the Erlang VM, you can add them into the VM args file. You can also pass them as command line arguments for all commands. It's also important to prevent EPMD from running because it can't be secure. For the secure network, all the nodes in the network need to work as both TLS server and client. In the settings shown in the right figure, both verify and fail if no pure cert are important. Verify pure ensures verification of a certificate before the connection is established. Fail if no pure cert ensures that the connection is never established if an appropriate certificate is not provided. It is a so-called mutual TLS connection. The network is secure because all the connection is established only after authentication by certificate passes. The second one is about Broadway. Pratipad heavily depends on it. Broadway is an Elixir library to build data processing pipelines. It reached version 1.0 recently, and the team published such a great website shown in this slide. Pratipad is built on the top of Broadway. We'll dig into how Pratipad uses Broadway. Broadway adopts the producer-consumer pattern to implement the data pipeline. Broadway officially provides some producer implementations for Amazon SQS, RabbitMQ, or others, and it allows us to make custom producers for our own purpose. Off-Broadway OTP distribution is a custom Broadway producer I made. It works as an adapter between our nodes and the Broadway pipeline. Pratipad handled the two Broadway pipelines at this figure. Forward Broadway is for the forward Dataflow and vice versa. Messages flow forward from the device layer to the cloud layer through the edge layer. If the cloud application needs to send back some message, it sends the message through the backward Broadway. It is how Pratipad realizes the bidirectional data flow. Let's dig deeper. This figure shows how messages flow. Pratipad client is a message sender and receiver for the Pratipad data flow. First, it establishes a connection to the Broadway pipeline. Second, it sends messages to the producer running as part of the pipeline. Finally, it receives messages sent from the other side. Messages can be processed and transformed in this data flow. We'll see the details later. Data acquisition method in IoT systems can be summarized into the three ways: push, pull, and demand. Pratipad supports all of them. I'll explain how they are different. The first one is the push method. It's the simplest way to retrieve data from the devices. In this method, devices just send messages as they like, typically in a periodic manner. The device layer is responsible for how many messages are emitted into the data flow. If you need real-time data retrieval, this method is what you want. The second one is the pull method. In this method, cloud application asks for the devices to send messages, typically in a periodic manner. The cloud layer is responsible for how many messages are emitted into the data flow. If you need to control the message flow rate along with the service level of your application, this method is what you want. The third one is the demand method. It is the characteristic method provided by Broadway. In this method, the edge pipeline asks for the devices to send messages only when it's capable of handling messages. The edge layer is responsible for how many messages are emitted into the data flow. If the edge layer can be rate limiting, this method is what you want. The third one of the details of the Pratipad framework is about data flow notation. Pratipad provides data flow notation. It's implemented with Elixir macros. You can describe a data flow as the example at the right figure. First, as the word push denotes, messages are sent to the data flow from the device layer. Then, the messages are processed and transformed. Finally, they are sent to the cloud layer. And this description also means the data flow is bidirectional. Pratipad provides a mechanism to process and transform messages on the data flow. We call it a processor here. In the upper right figure, processors are described as P1, P2, and P3. Actually, they are Elixir module names. These names are linked to the module implementation like the lower right figure. Processors are supposed to implement Pratipad processor behavior, and the process method will be invoked to do something you want to do with messages. This table summarizes the notations of Pratipad provides. There are three types of notation, such as input, processing, and direction. The input notations are to describe which data acquisition method you want to use. The processing notations are to describe how you want to process messages. We'll look into this on the next slide. The direction notations are to describe the direction of the data flow. Pratipad provides two ways for message processing: sequential and concurrent. Sequential processing can be used when you want to process messages step by step. That is, each processor transforms the message and passes it to the next processor. Concurrent processing can be used when you want to do based on the message content. Typically, for such a case that you want to send the message content to some external storage. Elixir has a great ability to let users implement their own syntax. The data flow notation is realized using Elixir macros. The implementation shown in the slide handles the arguments from left and right, and builds a struct that includes all the information about the data flow. Please look into the source code published on GitHub if you want to know more about how the notations are implemented. As mentioned earlier, messages are sent from the device layer to the cloud layer through the edge layer. However, I omitted there the details of how messages are processed. Actually, in the Broadway pipeline at the edge layer, the handle message function handles the messages and sends them to processors described in the data flow. After the processing, the messages will be sent to the cloud layer via the handle batch function over the distributed Erlang network. This is the full picture of how Pratipad handles messages based on an easy-to-grasp data flow description. So, it's time to wrap up. I think the Internet of Things can be realized well by the distributed network of Erlang nodes. As we see in this talk, Elixir can implement all the layers of IoT systems, and it can keep the network secure even if we adopt the distributed Erlang protocol. I'd like to see such a world where all the things connect each other as Erlang nodes. I hope Pratipad can be of help. And I'm now wondering if we can provide the distributed Erlang network in a multi-tenant manner. I'd like to talk about it at the next stage. Thank you for listening to my talk. Thank you.